So guys, we had a good discussion on UDP protocol. Now let us discuss the big brother of UDP protocol, that is Transmission Control Protocol or TCP. So TCP protocol is a way more complex protocol as compared to UDP, and it is a result of a research of over 20 years. So now let us understand the properties of TCP protocol. So you can see in the diagram on the right hand side, we have a sending machine S and the recipient machine R. And these two machines are present somewhere in the network in between. Now there is an application A which is running on machine S, and this application A is listening on TCP port number 100. The IP address of the machine is 10.10.1.1. Similarly, the recipient machine R is running an application A which is running on TCP port number 10. And the IP address of the recipient machine is 10.1.1.1. Right? Now the very first property of the TCP protocol is that TCP protocol is a connection-oriented protocol. It simply means that the sender and the receiver have to be mutually agree with each other before carrying out any application data exchange. So let us try to understand this point in detail. So you can see in the below diagram, this is the application which is running on the sending machine S. And this application wishes to carry out data exchange with the recipient process running on machine R. So the very first thing the application does is to ask the TCP protocol which is running in the transport layer to say hello to the recipient process. So of course the application conveys the TCP protocol that, hey TCP protocol, just say hello to the process A which is running on TCP port number 10 on the recipient machine R whose IP address is 10.1.1. So the TCP protocol which is running on the machine S in the transport layer, having received this hello order from the application, simply sends the connection request to the recipient machine R. In this connection request, the TCP protocol running on the sending machine conveys the recipient process its own specification, that is the TCP port number of the sending process and the IP address of the sending machine. In addition to this, the TCP protocol running on the sending machine also conveys its processing capability to the recipient TCP protocol. In this simple example, the TCP protocol on the sending side is telling the TCP protocol on the recipient machine that, hey, I cannot process the data more than 5000 bytes per second. So if you want to send data back to me, please do not send it at the rate of more than 5000 bytes per second. Now in response to this connection request, the TCP protocol running on the recipient machine sends the connection acknowledgement reply to the sending TCP. Right? Now in this connection acknowledgement reply, the recipient TCP conveys its own capability to the sending TCP. So in this example, the TCP protocol running on the recipient machine R is conveying the TCP protocol running on the sending machine S that, hey, I can process the data at a maximum rate of 1000 bytes per second. So if you want to send data to me, please do not send it more than 1000 bytes per second. So you can see that in the exchange of these greetings between the sending machine and the recipient machine, the TCP protocol running on the sending machine and the receiving machine actually exchange their capabilities also. So when the sending TCP receives the connection acknowledgement reply from the receiver TCP, then the connection is said to have established. Right? So note that in the connection establishment procedure, there is no actual exchange of data, but rather there is only exchange of connection request and connection acknowledgement. It is only after connection establishment that actual data exchange takes place. So when I say that TCP is a connection-oriented protocol, it simply means that sending TCP and recipient TCP has to mutually agree with each other that they really want to participate in data exchange. And if they really want to participate in data exchange, then they should exchange their capabilities also. Here, capabilities means that how fast each of them can process the data coming from the other. Surely we will going to deep dive into the complete procedure of connection establishment between the sending TCP and the recipient TCP in great detail when we will be discussing the TCP protocol in the subsequent section of this course. So guys, continuing with the discussion of TCP protocol, the second property of TCP protocol that we will going to discuss is that TCP protocol is a stateful protocol. Now stateful means that TCP sender as well as TCP receiver keeps track of the data that is being sent and received, right? So you can see in this diagram, the TCP sender and the TCP receiver have already established the connection successfully, right? Now, after establishing the connection, the TCP sender and receiver will now start exchanging the data with each other. Now, since TCP is a stateful protocol, it means that TCP on either ends, that is on the sender end as well as on the receiver end, will keep a track of a data that is being exchanged with the other side. For example, the TCP on the sending side will keep the information about data such as how many bytes of data has already been sent. In this case, for example, let us say that 100 bytes of the data is already sent and 500 bytes of data is yet to be sent, right? The TCP on the sending side is also keeping a track that 200 bytes of data has already been received from the receiver R. So remember, the TCP connection is a duplex connection. The flow of data happens in both directions. The TCP also keeps a track that which byte needs to be resent. The byte needs to be resent if in case it did not reach its intended recipient. So you can see that TCP keeps a track of the data that it is interested in exchanging with the peer. Similarly, TCP on the other side keeps a similar track of the data it is interested in exchanging with the peer. So because TCP does the housekeeping of the data, therefore TCP is called stateful protocol. So takeaway is that TCP is a stateful protocol because the TCP protocol keeps a track of all the bytes of the data which it is interested in exchanging with the peer. So guys, going forward, the TCP is a byte-oriented protocol. It simply means that the TCP protocol send and receive the data as continuous flow of bytes. This is analogous to like flow of a water through a pipe, right? TCP ensures that every drop of water, here the drop of a water means byte, right? So TCP ensures that every byte of data is received by the receiver successfully. Every byte of data is tracked by a TCP protocol. So you can see that the TCP protocol actually monitors every byte of data, and therefore TCP is called byte-oriented protocol. Even if one byte of data is missed or lost in the network for some reason, the TCP protocol on either side will collaborate together to ensure that the lost byte is recovered and is retransmitted by the TCP sender so that it reaches the TCP receiver successfully. So remember, because TCP does the housekeeping of a data at a byte level, therefore TCP is called byte-oriented protocol. TCP doesn't keep a track of the data at the packet level, but rather it keeps a track of the data at the byte level. So TCP is quite a robust protocol. TCP is also able to handle out-of-order delivery of the packets at the receiving end. So you can see in this diagram we have an application which is running on the sending machine S, and we have an application which is running on the receiving machine R. Suppose the application generates two packets, the packet 2 and the packet 1. Now you can see that the TCP on the sending machine S has injected two packets in the network. The first packet that was injected is the packet number 1, followed by the packet number 2. Now this is an open internet. An open internet is an uncontrolled entity. Anything can happen anytime. The packet 1 and 2 can actually take different paths to actually reach a recipient TCP. So you can see on the receiving end, we have assumed that the packet 1 and 2 actually arrives in the opposite order. Let's say that the packet 2 arrives first, followed by packet 1. So TCP protocol which is running on the receiving end will actually accumulate the packets which arrives out of order, and until it ensures that all the packets have arrived, then the TCP on the receiving end again rearranges and reorders the packet, and then it delivers all those packets to the application in the correct order. So TCP protocol on the receiving side implements the procedure to handle out of order delivery of packets from the sending TCP. TCP protocol on the receiving side ensures that data is consumed by the receiving application in the correct order. So guys, going forward, the last property of the TCP protocol is the reliable delivery. This is the most important feature of a TCP protocol. In fact, the TCP protocol has been designed to actually possess this special property. It is this property which makes a TCP protocol poles apart from the UDP protocol. So reliable delivery ensures that all application data are delivered to the recipient and none should be missed, right? TCP sender and receiver jointly implements reliable delivery procedures. So note that TCP sender and the receiver has to work jointly in order to ensure that all the data which is generated by the sending application has been delivered to the recipient application in the lossy network. The procedures which TCP implements to ensure reliable delivery are collectively called as automatic repeat request, abbreviated as ARQ. So you can see in the diagram below, we have an application and the sending TCP, and we have an application with the recipient TCP. So suppose the sending application generates two packets, that is packet 1 and packet 2, and the sending TCP injects these two packets in the network. Now let us assume that our network is not perfect and it is lossy, right? The network could be lossy because of thousands of reasons. Now let us suppose that these two packets during their journey on the network, let us suppose that the packet number 1 gets lost and it is only packet number 2 which reaches the recipient TCP. So now recipient TCP will keep this packet in its local memory and it will not deliver this packet to the application because the recipient TCP also expects the packet 1 in order to ensure in-order delivery of the data to the application. So now what will happen that the sending TCP and the receiving TCP will jointly work together to figure out that the packet 1 has been lost. Now the procedure behind detecting whether the packet has been lost or not is a complex procedure and is a wide topic of discussion. For now, let us assume that the sending and the receiving TCP collaborate together to figure out that packet 1 has been lost. Now as soon as the sending TCP comes to note that the packet 1 has been lost, it retransmits the packet number 1 again. The retransmission of the lost packet is called automatic repeat request. So eventually the packet number 1 will going to reach the recipient TCP, right? So the moment the recipient TCP figures out that it has received the packet number 1 as well as the packet number 2, it will deliver both of these packets in the correct sequence to the application. So you can see that TCP protocol ensures reliable delivery of the data. One should use TCP protocol in order to facilitate communication with the remote machine in case the network is suspected to be lossy. The other reason for using TCP as an underlying protocol for communication between applications is that the application that are involved in communication actually exchanging the critical data.